Hello friends, in this video we will be seeing DDL portion of Hive. So before getting into this, let us recap what we are talking about. So to begin with, when I spoke about agenda, I told that the flow will be like this. First we will be creating the Hive databases, then we will be doing the physical data modeling, which means creating Hive tables, and then we will be extracting and loading data into Hadoop, primarily using Scoop or MapReduce or Hive, and then transformations and then workflows. So uh, to cover all those things, we will follow this process, and I have already spoken about Hive architecture. Now I will be talking about Hive DDL, which stands for Data Definition Language, as in any RDBMS or data warehousing technologies. So before getting into details about DDL, let us see the major differences with relational databases. The first one is there is no support for real-time indexes in Hadoop or Hive. So I never created indexes. I primarily focus on proper partitioning when I try to create Hive tables. So I haven't explored much about indexes so far. But as far my knowledge goes, indexes are static. You cannot actually have indexes on tables that are being modified at regular intervals. So if more and more files are added to the tables in Hive, you have to rebuild the index. So index is nothing but sorted file. So there is no support or minimal support for real-time indexes. As you see in traditional RDBMSs or data warehouse technologies, you will have their own programming language. So for example, if you are using Oracle, then you have PL/SQL. If you have SQL Server, then you will be using T-SQL. If you are using Informix, then you might be using 4GL. If you are using Teradata, there will be Teradata PL/SQL or something. And as part of that, you see packages, procedures, functions, triggers, and all those things in traditional relational databases or even data warehouse technologies. In Hadoop or Hive, you don't see packages or procedures or functions. You don't see triggers. If you have to program something, you have to use Java or some other programming language. You have to use JDBC to connect to Hive, and then you have to process the data. You can, and there is no specific programming language that is related to Hive. And there is no range partitioning. So if you are familiar with Oracle have three types of partitionings: list partitioning, range partitioning, and hash partitioning. So when it comes to Hive, there is no middle one, range partitioning. Yeah, there is list partitioning. In Hive, partitioning means list partitioning, and bucketing means hash partitioning. So there are many types of partitionings in Oracle if you are from Oracle background, but these three are the most famous ones: list, range, and hash. And there is no range in Hive. There is only list and hash partitioning, and hash partitioning is called as bucketing. And there are very limited data types, primarily numeric and string. I think recently they have added timestamp, but there is no data type for date. So we will see those things in detail later, but these are very high level differences between traditional RDBMSs when you and the Hive databases, DDL in Hive. So Hive DDL, we tend to create databases, we create and manage tables, and we need to be aware of physical data modeling when you try to create tables in Hive. So in the context of enterprise data warehouse, we will be creating one or more databases for staging. So if you go back to this picture, uh, due to the limitations in Hive, even before so ODS and DDW are the main databases, and there can be n number of staging databases to support these two main databases, which is ODS, Operational Data Store, and DDW, Enterprise Data Warehouse. So due to that, we might have to create one or more databases for staging. In some scenarios, you might have to create one database per day using a timestamp in the database name, and you should delete older databases in a cyclical fashion. So there can be any number of staging databases, and there is no harm in creating as many databases as we want in Hive. And then we will create at least one database for ODS and one or more database for EW. So it all depends upon how you want to manage your databases. So now let us see the syntax, basic syntax of creating Hive database, which we have seen earlier. We have created a database called cards. Now we will try creating databases for our retail DB. So we will name it as retail underscore ODS and retail underscore EDW for ODS and EDW, and for staging we will see whenever it is required. So I am updating the script. So we are trying to create a data warehouse for retail DB, which is in MySQL. So the syntax will look like this: create database. If not exists is if database does not exist. If you do not want to error route, then you have to include if not exists. So the purpose of this is when you actually include it in scripts, if you don't want to error out for the databases that are already existing, or even for the tables that are already existing, you can use this clause if not exists. If the database already exists, it will just come out without any error. If the database does not exist, then it will try to create the database. So let us name the ODS database as retail ODS, and then create database uh, retail underscore EW. Okay, so we will create these two databases, and let us go to the um, Cloudera VM, and let us copy these two scripts, and you can run the dfsls command. So there are no all the databases will have the extension .db, and this let me explain about this user Hive warehouse as well before creating the database. For that, let me open another terminal. Okay, and let us go to the configuration files. As I have mentioned earlier, Hive configurations will be under etc hive conf. You can do lsldr, you can do view hive site.xml and warehouse. Okay, in the latest versions they don't have this parameter. That is fine. So by default, this will be the base location for your Hive database. So for user Hive, there will be a directory Hive, and then warehouse is the base location for all the databases of Hive. So in this case, this user warehouse is default value. If in some cases you might not find anything here, in that case you have to go to your hivesite.xml file or hive default.xml file, and you have to look for this parameter and the corresponding value, and you have to look in that location. In this case we are using default values, so looking at user Hive warehouse is more than good enough. Now I am pasting those two create database commands, and now let me run user Hive warehouse. If you see, now you can see two directories with .db extension. So here the first bit will tell you whether it is a directory or a file. So these two are directories, and for any database that is created using create database command, you will see a directory with .db extension. That's how Hive distinguishes between a database and a directly related to a database and a directly related to a table. And if you want to create tables in a particular database, you have to switch to that database like this using use command, and then you can create the tables, which we will see later. Okay, and we have created ODS and EW. Now we will talk about data types. Okay, so in traditional databases, you will find plenty of numeric data types. Same is the case with Hive. You have all these data types: int, small int, big int, float, double, decimal, etc. For character, there is only string, whereas in traditional databases you will see char, varchar, varchar2, glob, etc. But in Hive there is only string, and you don't specify precision, so you just define it as string. Whereas in traditional RDBMSs you typically have precision for char, varchar, and varchar2, like char of 10, char of varchar of 30, something like that. And for binary, there is a data type called binary in Hive, which is typically represented blob in traditional databases. And Hive supports complex data types, array, struct, and map, which is out of the scope of this course. You can explore them. If you have basic understanding of Hive, going through these complex data types, you will easily understand the rationale behind it. So now we will talk about to create drop or truncate tables. When you actually create tables, like we have seen as part of our script, um, so this is how you will specify data types. In traditional databases, you will have the precision as well for string types, whereas in Hive you don't have that. And then you typically don't see this in traditional RDBMSs unless it is external table. You don't see something like this. If it is external table, even in traditional databases, you have to tell what is the delimiter of each of the columns in the table. Here, all the tables are treated as external tables. Uh, so Similar to external tables, so you have to define delimiter for almost all the tables. If you do not define, it will take some default values and it will expect data to be in line with those default values. And then stored as text file will tell you how the files will be stored. So there are bunch of file formats. By default it is text file, so if it is text file, data will be read as text file. If it is binary file, you have to store it as sequence file. So depending upon the data file types you are trying to store into Hive tables, you have to change the stored as clause. So you need to be aware of all the possible values under stored as. So this is the basic create table command. Okay, and the file formats, as I have explained earlier, you can specify whether it is text file or sequence file or some other file depending upon the requirement. And you will see two types of tables in Hive: external and managed tables. External, don't get confused or relate the external tables in Hive with external tables in the traditional databases. In Hive, all the tables are similar to external tables in traditional databases. There is only one difference. There are few differences. One is in the create table syntax itself. So let me show you. If you want to not this one, I have to look at this one. Yeah. So the two main differences between traditional table and managed table and external table is this one. So you will have, Let me tell you. Everything will be same. In the end, you will have the location as well. So you have to specify the location for your table. So we will see more about it when we actually run the commands, and you have to pass the location here. Or I will actually update this file with a right syntax of external table. So there are certain differences in the syntax. One is the external clause in the table definition, and then the location clause. In the managed tables, you will not typically see the location clause, whereas in external table you have to specify the location, otherwise it does not know uh, uh, where the files are. Okay, so on top of that, the second major difference between managed table versus sectional table is that when you actually drop the managed table, the directory that is related to the table. So for example, when you go back to here and switch to use cards, switch to cards database, and you can see tables by using show tables command, and you can see uh, details of the table by using describe formatted command. So and by passing the table name. So describe formatted table name, it will give you the location of the table and table type managed table, and it will give a lot of other information too. So when you actually drop a managed table, this directory will be lost. So for example, if I try to do drop table deck of cards, and if you try to look at this location, this is how you can actually read the details about your HDFS. Sorry, paste. So it is gone because we dropped the table, the location is gone. If it would have been external table, the location will not be gone. Only the metadata will be deleted from the Hive metastore, but the actual data and the directory will be intact in HDFS. So that is another major difference between a managed table and external table. So there are two differences. One is syntax difference, second one is functional difference. And the functional difference is when you drop a managed table, data will be gone along with the directory, whereas external table data will not be touched. Only the metadata will be gone from the Hive metastore, which is MySQL database in this case. And it is very important interview question, so keep in mind about this. And why what is the use of external table? So the main advantage of external table is if you are using the same HDFS location by multiple tools other than not only just Hive but also other tools like Hive, Pig, Scoop, and also Java MapReduce programs. In that case, if you create it as a match table, when you drop Hive table, all the other subscribers to that location will get impacted. But if it is external table, there won't be any change in the HDFS. So only users that are using Hive and that are accessing the data under the directory using Hive will be impacted, which is the requirement. All the other users or tools that are subscribed to use that location will not be impacted. So uh, that is the purpose of external tables. And if you want to create a table solely to work using Hive, then you should go with managed table. Now going back to this presentation, there are non-partition tables. So the examples which I have shown are non-partition tables. You can create table using create table as select command, which is called CTAS in short. So and you can actually partition the tables by using partitioning and bucketing, and as I have shown you, you can actually describe the tables as well. And Hive also supports views, uh, uh, and uh, and now we will talk about physical data modeling. I will show the demo of each and every thing, each and every of these things in the context of retail DB in the next video. For now, let us complete the theory, then we will work on the demo. So for physical data modeling, you have to keep all these things in mind. File formats. So we will be dealing primarily with text data, and also I will try to show you Avro and sequence files. So we will see multiple file formats as part of the demo. But what you need to keep in mind is, depending upon the format of the file, you have to define stored as clause. Otherwise, you will run into some issues. And when you are doing physical data modeling in Hive, you have to change the data types. So as I have explained earlier in this slide, there are certain differences between traditional databases and Hive. And if you want to create tables using the traditional databases as a reference, then you have to make all these adjustments. And you have to determine the delimiter, field and the line delimiters. Line delimiters is new line character by default, but if you want to define some other delimiter, you have to define why as part of your create table command. So you might have to determine formats for null values. So you can go through the documentation for reference. And typically, when it comes to physical data modeling using traditional RDBMSs, redundancy will be used as last resort. So, for example, you have a fact table and you want to generate reports in multiple dimensions. So, one is date dimension and the other one is region dimension. So, when it comes to orders, in our case, I'm going to MySQL -u root -p Cloudera, use retail underscore DB and describe orders. So orders have order date and customer ID. So using customer ID, you can actually describe customers. You have cities and states. So you can actually using the orders data and customers dimension, you can actually generate a report uh, which can be based on the region dimension. Similarly, using the date and joining with the date dimension, you can actually generate reports based upon date dimension like daily, weekly, monthly, quarterly, yearly, etc. So, but the fact data is the same, which is orders, but you can visualize both in date dimension uh, uh, as well as region dimension using the same orders data set. In traditional RDBMSs, what you will do is you can create a fact table partitioning on one dimension, for example date, and then creating index on the other dimension. So you can have one copy of data and you can actually generate reports in two different dimensions. Whereas in Hive, where there is a minimal support to indexes, that is not possible. So you might have to clone the same data into two different fact tables, one partitioned by date and the other partitioned by city or region, so that you can actually generate reports in both the dimensions more effectively. So in short, when it comes to physical data modeling in Hive, redundancy is one of the top criteria you have to think through in the beginning of the project itself, whereas in traditional RDBMSs or data warehouses, you will try to avoid redundancy as much as possible, because the storage is very expensive in traditional RDBMSs, whereas storage is very cheap in Hadoop based databases. So redundancy should be one of the top criteria when it comes to physical data modeling in Hive. And then accurately determining partitioning or bucketing strategy is key. So first you need to remember that there is no range partitioning in Hive. So in certain cases you have to simulate the range partitioning using list partitioning itself. So and also you have to understand the bucketing, which is hash partitioning as well. So depending upon your requirement, you have to either use partitioning or bucketing, which is list partitioning or hash partitioning. That is another criteria which you need to think about while physical modeling in Hive. And last one, which you need to keep in mind when you actually do physical modeling and start creating tables in Hive, is too much partitioning versus too little partitioning. So if it is too much partitioning, then you might end up with too many small files, which is not good for Hadoop. And if it is too little partitioning, and then your ETL can take abnormally long time. So let me give you an example here. If let's say you have orders data, and let's say you partition by year to avoid too much partitioning. So when you partition by year, let's say for each year you have 10 GB of data, okay, or 12 GB of data, 1 GB per month. And if you have report requirements of daily, weekly, monthly on the same data set and also quarterly, so even to run daily report, you have to process 12 GB of data every day, which might not be a very good decision. So for that reason, instead of partitioning yearly, if you go with daily, so if it is yearly, yeah, each partition will have 12 GB of data, and most of your reporting requirements are daily, and each partition for each report you are processing 12 GB of data, which is unnecessary processing. So instead, if you partition more frequently than yearly, performance might be better. So for that, let's say you consider daily partition. So when it comes to daily partition, yearly data is 12 GB. That means monthly data is 1 GB. That means daily data is around 30 MB. So you will have data on you will have file on average of 30 MB size, which is again not good because of too many small files. So you need to understand from this context, and you have to determine an appropriate partitioning strategy. In this case, probably partitioning by weekly might be a good idea, because even for daily partition, instead of if you partition by weekly, you just have to process 256 MB of data, which is not bad. So you have to keep this in mind: too much partitioning versus too little partitioning while doing the physical data modeling. So being said that, that is it about, and also you have to keep all these concepts in mind: facts, dimensions, star schemas, snowflake schemas, roll-up tables, report tables. If they are dimensions, the type 1, type 2, type 3 dimensions, you have to think through all these things, and then you have to come up with your physical data model. Okay, we will see few of these things as part of the demos. So for now, Hive physical modeling theoretically is done, and in the next video I will try to demonstrate by creating a few databases and also few tables using partitioning. I will explain how to translate a traditional RDBMS table into Hive table, and also I will explain more about file formats, partitioning, views, all those things in detail as part of the demo. Okay, so far we have covered. Let me go back to the agenda. So far we have covered Hive architecture and Hive DDL theoretically. In the next video I will do the Hive DDL demo, and then we will start talking about scope in detail. Okay, thank you very much. Have a see you as part of the next video.